The activation of autophagy, our cell's intrinsic cleanup system, is one of the most exciting frontiers in the science of healthy aging. Autophagy helps eliminate damaged organelles, misfolded proteins, and accumulated cellular waste, thereby reducing inflammation, supporting mitochondrial health, and enhancing resilience to metabolic stress. Fasting is one of the most well-established triggers of autophagy, but prolonged fasting or very low-calorie regimens can be difficult to maintain and may carry risks for certain individuals. This has given rise to fasting-mimicking diets, FMDs, and more recently, to interest in whether micronutrient-tuned diets, nutritionally complete yet metabolically targeted, can activate autophagy just as effectively. The question is compelling. Can precise micronutrient control replicate or even improve upon the cellular benefits of fasting? Fasting-mimicking diets aim to simulate the cellular stress of fasting without complete food deprivation. These short-term regimens, usually 3 to 5 days, are low in calories, protein, and sugars, and designed to blunt insulin and IGF-1 signaling, reduce mTOR activation, and trigger autophagy while providing enough nutrients to avoid malnutrition. Pioneered by researchers like Dr. Walter Longo, FMDs have been shown to promote autophagy, reduce systemic inflammation, support metabolic flexibility, and even promote stem cell regeneration. They represent a strategic way to cyclically stress the body into repair mode without imposing the burden of long-term starvation. However, FMDs are still based on a deprivation model. They work by creating a controlled nutrient deficit, mimicking starvation just enough to activate energy-sensing pathways like AMPK and inhibit mTOR, two of the central regulators of autophagy. This makes them powerful but transient tools. The benefits occur largely during the fasting-mimicking period and taper off once normal eating resumes. Moreover, their restrictive nature may not be suitable for all individuals, especially older adults, those with low body weight, or individuals with certain medical conditions. Compliance can also be difficult for many. On the other hand, micronutrient-tuned diets aim not to mimic fasting through calorie restriction, but to stimulate similar metabolic pathways through nutritional precision. These diets focus on maintaining optimal levels of vitamins and minerals that are known to influence autophagy, mitochondrial function, and inflammation, often in subtle and cumulative ways. Key micronutrients such as vitamin D, B3, as NAD, precursors, magnesium, selenium, zinc, vitamin K2, and antioxidant cofactors like CoQ10, polyphenol, and alpha-lipoic acid all participate in the regulation of AMPK, mTOR, and sirtuin pathways. For example, vitamin B3 in the form of nicotinamide riboside, NR, or NMN increases intracellular NAD, which activates sirtuins, enzymes that promote autophagy and mitochondrial repair. Magnesium and zinc are necessary for proper AMPK activity, while vitamin D modulates mTOR and supports autophagic gene expression, particularly in immune and epithelial cells. Selenium and vitamin C reduce oxidative stress, which can otherwise impair autophagic efficiency. Some plant compounds like resveratrol, quercetin, and EGCG from green tea also mimic calorie restriction at the molecular level by activating the same energy-sensing pathways. The strength of micronutrient-tuned diets lies in their ability to support ongoing, low-level autophagic activation without inducing stress or catabolism. Unlike FMDs, these diets do not rely on significant calorie restriction and therefore preserve muscle mass, hormonal balance, and energy levels. They are also compatible with real-world lifestyles, making long-term adherence much more feasible. Over time, consistent optimization of micronutrients may provide a more sustainable way to engage the autophagy machinery and reduce the cellular damage that drives aging. However, it is important to acknowledge that micronutrient tuning likely does not activate autophagy as aggressively or acutely as fasting or FMDs. The stress signals required to trigger autophagy are most powerfully generated when cells experience energy scarcity. Without this pressure, the autophagic response may be mild or incomplete. That said, the goal isn't always maximum activation, but optimal activation, balancing cleanup with the need to maintain function, strength, and cognitive clarity. A well-designed micronutrient strategy supports these goals by enhancing the cell's readiness to engage in autophagy when needed, even if the trigger is less intense. In fact, the most powerful approach may lie in strategic combination. Using a micronutrient-optimized diet as a foundation, Periodic fasting mimicking cycles can be layered in to deliver controlled bursts of deeper autophagy. This model harnesses the best of both: steady-state support for cellular function and immune health from nutrient sufficiency, plus the rejuvenating cellular reset from intermittent autophagic activation through fasting signals. For example, one might eat a micronutrient-dense, low-glycemic diet most of the month, and once or twice monthly engage in a 3-day FMD to induce a deeper autophagic response. This cyclical model better reflects how humans likely evolved, oscillating between abundance and scarcity, but always with adequate nutrient intake during refeeding periods. In conclusion, fasting mimicking diets and micronutrient-tuned diets are not mutually exclusive, but they differ in their mechanisms and intensity of autophagy induction. FMDs deliver powerful short-term activation through nutrient stress, while micronutrient optimization promotes ongoing autophagic competence through metabolic balance and mitochondrial support. For those seeking the benefits of cellular cleanup without the strain of prolonged fasting, a micronutrient-rich, low-glycemic, well-timed diet may offer a safer and more sustainable path. But for those capable of tolerating brief periods of fasting mimicry, layering both strategies could yield the deepest and most comprehensive anti-aging effects, enhancing cellular renewal without compromising nutritional integrity.